So, welcome back. This is really where the money is at, because this time we're going to be looking at RAG assessment, and this is a library that's got tools in it which are going to help us to evaluate our RAG system. And assuming we've got some sort of RAG system that kind of works, the next thing we're going to want to do with that is we're going to want to optimize it. We're going to want to make some change to it, and we're going to need some method of evaluation to see if our newly configured system is better than the original system or not. And so this is the basic idea of RAGAS. So when we look at RAGAS, there's a lot of stuff that goes on in the background. It involves a large language model which is doing various things, splitting up all our context and asking various questions of the information that we provide it. And so this RAGAS is very nice because all of this hard work behind the scenes is taken care of. We just need to provide it with a data set. So what is the data set that it needs? Well, if we just jump over to some Scratchpad, get rid of that, and so essentially if we zoom in here, we are it's gonna require a data set which has got three things. The first one is lists of questions. The second thing is lists of document chunks, which I will call the context, that we're going to provide to a large language model to generate some response. And this data set is going to include a ground truth response. Now, this ground truth response is basically going to be the theoretical perfect answer to our question. In an ideal scenario, we can maybe get humans to answer these questions. We're going to say, hey, look, here's the question, here's the context, write me what the perfect answer is. But in reality, I mean, who is going to have time to annotate thousands of these things? So in order to do this, we're going to use a powerful large language model to generate this ground truth. Now, that's the data set that we're going to require to conduct the assessment. We're also going to, we're going to be assessing our RAG system, and our RAG system is going to be assessed on its ability to answer these questions. So this is what our system looks like. It gets some questions, and then our embedding model is going to retrieve some of these contexts, which we're going to provide maybe 1, 2, 3, and then here it's going to provide some, what I'm going to call some system response. Okay, so we've got the system response, and one reason that this ground truth answer might be better than a system answer, one of the reasons that might be, is because here we are getting some context by our embedding model. We don't know if they are the most relevant documents to answer the question with. And so the system is answering the question based on some context which we're uncertain about, whereas this ground truth data set, we knew the questions, they were generated from a certain item of context, and it is guaranteed that the context is relevant to the question. So that's why this ground truth is basically the gold standard for which we're going to measure ourselves against. So if we just head back into RAGAS and just have a little look at some of the metrics which are available in RAGAS. This first one is context precision. There's this metric of precision at K, which is important evaluation metric in RAG systems. So this is just basically a take on that. And basically what it is, and I'll just jump back in for a second then to this little sketchpad, is that we're going to have some sort of return from our embedding model, the information that we're going to pass in the context to the large language model, and we're going to ask the question about the purity of this list. And in an ideal scenario, then what we're going to want is that this is relevant, and that this is relevant. And in which case, we are going to get a top score. But maybe, for example, here we've got one irrelevant document at position number 3, then the score is going to diminish. But if you can imagine, in that scenario, we got 2 out of 3 correct. We can imagine getting 2 out of 3 correct here, but the first item is incorrect. Now, because this is supposed to be our strongest answer, this is our biggest recommendation, this metric will take into account not just the number that are relevant, but it will also take into account the position. And so it's, of course, a lower score if your top documents are wrong. So back to the notebook. That's context precision. It's sort of measuring. It's measuring how pure lists of recommendations are. And the full explanations are going to be in this notebook. You can hit the link to the GitHub repo and find that. The next metric then is going to be context relevancy, which is basically going to split up the information into context, into sentences, and ask the question, how much of them are useful for answering this question? So that's context relevancy. I won't dwell on them. Context recall is more of a test of the large language model, and it's going to be splitting up the ground truth answer into sentences and asking, well, what proportion of all these sentences in the, or what proportion of the sentences, of the total sentences in the ground truth can be attributed to the information in the context. So here we're looking sort of at hallucination. Is our large language model sort of inventing lots of stuff, or is the stuff coming directly out of the information that we've retrieved with our embedding model? So the next concept, the next metric that we can potentially use is context entities recall. And so this is going to basically split up our ground truth. It's going to identify all the entities in our ground truth. So an entity is going to be a linguistic entity. So in an NLP, we've got this task of named entity recognition. And the idea of that is maybe we've got some document, we want to find all the person or all the people entities in that document. And we essentially try and identify all the people in that document. So here we're not just talking about people, we're talking about any particular entity. And I suppose you can just think of that as a thing. We're going to look for things in our ground truth. And we're going to look for things, entities that are in our ground truth and that are in the context. And we're going to find the proportion of that, the proportion of the total entities that are also found in our context. So this is entities recall. The next metric is really quite nice. I can see it being useful in lots of cases. It's basically we're going to get some sort of answer from our system, and what we're going to do is we're going to reverse engineer the question. By using an LLM, we're going to say, look, here's the answer, what's the question? That's going to give us a question. We're going to compare that question with our actual question, the real question, and we're going to see how similar they are. So all that means essentially is we're going to put those questions into some embedding model. With that embedding model, we're going to get numeric representations, and we're going to measure the cosine similarity between those questions, the real one and the hypothetical one. And whilst we're still talking about similarity, answer similarity is another thing that we've got here, where we check the similarity between our system response and this ground truth ideal response that I was talking about earlier. And the answer correctness is going to take this answer semantic similarity into account, and also it's going to take into account how correct your actual system answers were in terms of are those facts actually correct. And so again, behind the scenes, we've got some sort of large language model at work making all of these assessments. And finally, then we've got this faithfulness metric. So this is the total count of claims in the response, and we've got claims which can be inferred from the context. So again, we're saying, okay, is this large language model faithfully sticking to the information which is in the context? So, like I say, before I go there, there are also some sort of ethical measures that you may or may not need. They're available there as well, but you can look in the RAGAS documentation and you can find all the information, and you can check this notebook and you can get the lowdown on all of these metrics. So we're at 10 minutes, so we'll continue on. Now, here we're dealing with a situation where we're asking a system to give us an answer to some question. The first thing I'll say about this is that it's going to be difficult, maybe even to define what the perfect response is. So any sort of system set up to evaluate is not going to be perfect. And so this RAGAS provides us with a number of metrics, but you've got to look very carefully at what they're actually measuring. A good proportion of them are not going to be useful for your particular use case. So you can't just look at this and say, okay, all the metrics have gone up, this is great. You really need to know what the metrics are measuring. Another thing to take into account is that just splitting your document into different chunk size is going to change these metrics, make them go up or down, and it might be that your system is improving but your metrics are going down just because you're splitting your documents up in a different way. So it's something to bear in mind. The other thing to bear in mind is that there's a lot of large language model going on behind the scenes in the process of this evaluation, and that is a potential source of error. That is, the final error from your system is going to have some proportion of that is just going to be the fact that our evaluation system is not perfect. So that needs to be taken into account. And because we're using these large language models, and we're using this ground truth data set, and we're probably using OpenAI now, and this might be costing us a lot of money to set this up. You can define your large language model, which are used behind the scenes, so it is possible, but just be careful and just be wary of the fact that this evaluation can start hitting your tokens with OpenAI. Another thing to think about is that you can have a metric go down in this scenario. You can have a metric decrease when your system has actually got better. And one possible example here is if you've used small to big and you've added a load more information to your large language model, well, essentially you're going to get some metrics which are going to go down because they're going to say, well, hang on, a lot of this information here is irrelevant to answering the question. However, your system is doing exactly what you want it to do, and maybe it's improving, but some of your metrics might be going down. Another thing to worry about here is there's a lot of interdependency in these systems. So maybe the best way of improving the response from your large language model is not improving your large language model, but it's improving your embedding model, which is going to give a better contextual information for your large language model, which is then subsequently going to give better responses. So there's a lot of interdependency, and it's difficult to maybe know. It's going to be based quite strongly on intuition, but what's going to be the things that's going to improve my metric the best. So I'm going to leave it there right now. We'll pick this up and we'll go through it in an example in the next video of exactly how we set up this RAGAS assessment.